Homework 9, Distance, Midpoints, and Circles, Video 1. This section is actually pretty easy and fairly straightforward. So, quite a relief from the past two sections. We're going to start with the distance formula, which we don't have yet, but we're going to build. Distance formula measuring the distance between 2 points on a coordinate plane. For example, let's find the distance between the points 2, 3 and 6, 5. Meaning, if we had a scale on the x-axis and the y-axis, as I have here, this scale is each 2 inches, but let's just pretend that each mark represents 1 unit. The question is, how many units long would this be? Now you might be thinking, can't we just mark up something on a piece of paper and put it down here? And I guess you could, but we don't want to have to do that because sometimes it won't be feasible. So is there a way to calculate the distance, without having to resort to such, primitive measures? And the answer is, of course there is. But to calculate the distance, we have to visit an old friend, the Pythagorean Theorem. I don't think we've talked about the Pythagorean Theorem in class, but regardless, most people know the Pythagorean Theorem as a squared plus b squared equals c squared. I don't like calling it that. It's not wrong, but if you ask somebody, what does that mean? Their usual reply is, I don't know. But the Pythagorean Theorem is actually a statement about the relationship between the 3 sides of a right triangle. Most people say a squared plus b squared plus c squared because this picture is associated with it. I prefer something much more descriptive. The longest side of a right triangle is called the hypotenuse. A lot of people tend to remember that. Why? I don't know. You rarely use the word. The other 2 sides of a right triangle are called legs. So to me, the better version of the Pythagorean Theorem is leg squared plus leg squared equals hypotenuse squared, which I'm going to abbreviate HYP. That way, you're not relying on something being called A or B or C because those names are completely arbitrary. These words have meanings and they connect it to this picture. So when I refer to the Pythagorean Theorem, I will almost refer to it as leg squared plus leg squared equals hypotenuse squared. So let's go back to the situation over here. How can I possibly use the Pythagorean Theorem on this picture? I don't even have a right triangle. But we can make one. If I were to ask you to calculate the slope of this line, you would probably calculate the run and the rise. Which would represent the horizontal and vertical displacement from the first point to the second. Look, a right triangle, and I can do the Pythagorean Theorem on it. I can say that the square of the distance is equal to the square of the run plus the square of the rise. Now we don't have either the run or the rise, but we know how to calculate them. To calculate the run, we just have to subtract the x's. I'm going from x equals 2 to x equals 6, so the run is equal to 4. And for the rise, I'm going from y equals 3 to y equals 5. These are just the numbers in the coordinates. And so the rise is 2. And so I can calculate the distance by simply substituting the 4 for the run, the 2 for the rise, and then going to town on this. 4 squared is 16, 2 squared is 4. When I add them, the square of the distance is 20. But we know how to unsquare something, square root both sides. Oh no, I have to use plus minus. Oh no, you don't. Algebraically speaking, yes, you should bring in a plus minus right here and say plus minus the square root of 20. But do you know why we don't need to use the plus minus here? We're calculating distance. Distance is positive. There's no need for a plus minus. Now, if this were a homework question, it would not accept the answer square root of 20 because they will expect you to simplify your square roots completely. In this case, you could break down the square root of 20 into the square root of 4 times the square root of 5 and get 2 times the square root of 5 as your final exact answer. Now, some questions in the homework will ask you to give an approximation to the distance, namely meaning if it comes out to a square root, put it in a calculator and give me a decimal answer. You can do 2 times the square root of 5, but honestly, it's easier to just do the square root of 20. So if I did the square root of 20, I would get to 2 decimal places, 4.47. Now, will you have to do every distance formula problem that way? Of course not. We were inventing the wheel, but I don't want to have to reinvent it every single time. So what I would like to do to conclude this video is to try to replicate what just happened on a generic level. In other words, what would happen if we tried to find the distance the same way, but we didn't have specific values for the 2 ordered pairs? So what would happen if we tried to find the distance between some generic first point, which we'll call x1 comma y1, and some generic second point, which we'll call x2 comma y2. Well, if we start here, we already know how to calculate the run and the rise. The square of the distance is equal to the run squared plus the rise squared. But when you calculate the run when finding slope, it's just the second x minus the first x. So that difference gets squared. And when you calculate the rise when finding slope, it's just the second y minus the first y. And that gets squared. And that almost gives us our formula. I say almost because we want a formula for distance, not for the square of the distance. So just drop a giant square root over both sides of the equation. That will cancel the square on the left, but it will not cancel any of the squares on the right. And the reason it won't is because a square root will not distribute across an addition sign. So you can't give the square root to each half. You can only give the square root to the entire problem. And so everything remains intact under the square root on the right side of the equation. And just like that, we have our distance formula. If you want to memorize the distance formula, that's great. If you want to understand the distance formula and always set up this right triangle, then you can just do the Pythagorean Theorem. Both of them will get the job done. In the next video, we'll take a look at another example that involves some negative numbers. It really doesn't change anything. You just have to be a little more careful.